I'm the operator with my pocket calculator.
Yes.
Now, the defining layouts of the Faber-Castell Elektro rules were fairly standard Ritz sort of scales. They had A and B, C and D. Some in the later versions had inverse scale on the slide. You usually had a K scale which could be placed either on the stator or the lower edge of the rule and read with a cursor extension. And also a logarithmic scale which again could be placed on the stator, on the reverse of the slide, or on the lower edge of the rule to be read by, again, a cursor extension. They also had a sine and tan scale on the reverse of the slide. And what they did to enhance the Ritz layout was to add two exponential scales indexed to the C scale over a range of about 1.1 to 100,000. And that was, if you're in electrical engineering, you're always dealing with exponentials for switching on, switching off of circuits. So they're ideal for calculating transients and transient decays. But the real scales that defined the Elektro was the two scales in the world. That's energy efficiency of motors and dynamos and a voltage loss in cables. Now, as you can see, these scales are actually pushed over that way. They're by a constant based on kilowatts and horsepower or PS. Now, the efficiency of motors and dynamos is a fairly trivial sort of calculation. All you had to do was convert horsepower to kilowatts and work out how much the input was and how much the output was, and that's it. That was the efficiency. So, although it seems like a good idea to do, it was a fairly trivial task to actually do it anyway. The voltage loss is a different sort of beast. If you look at an electrical circuit that takes from a generator to a motor or another industrial process, you run out cables. One hot wire, one neutral wire to come back. So you're going to, when current is transferring around that circuit, you have a voltage drop across the resistance of the cable or the impedance of the cable, and also back. You'll also have a voltage drop on the return wire. So therefore, the voltage available to this process or motor is really U0 minus U1 minus U3. So it drops by 2. So if you actually did your calculation on just the length of the wire, you would be wrong by a factor of 2. So therefore, as these dot points point out, the transporting power requires a return path. And using the resistance of the wire could not produce the correct total resistance, and therefore a factor of 2 required, as I've said. So designers of metric rules actually built this factor into their rules, whereas on the imperial side, they rarely did. It was usually just a one wire calculation. And the Faber-Castell rules usually had a gauge mark at 2.87, which is actually reciprocal of twice the resistivity of copper. Now, I'm in the old school, or the other school. I've actually preferred to work out on a single length. Why? Because the return path could be a different wire. It could be a different diameter of wire. It could be a neutral screen where the cable, the return path is wrapped around the initial hot wire. Could also be a combination of return paths, either the wire or an earth. Or in places where I come from, we have a system called single wire earth return, where you transport out 19,000 volts out via a single wire and through a transformer directly connected to the earth, and the earth path is the return for the current. So therefore, that a two-factor or a two-wire rule wouldn't have actually produced the right result in that one. So that's why I actually preferred the English system, which is a single wire calculation, because then I could actually work out the voltage drop across different types of wire and different return paths. Now, if we go back, how do I go back on this one, Carl?
Let me try if this now works. Here. Yeah, no.
Okay.
Fourth number.
If we go back to this type of rule, you can see here the makers actually put in what the scale constant were going to be, whether they're 10 amp, yards, or circular mils in the English system. Whereas in the continental system, it would have been 10 amps, 10 metres, and millimetres squared. Go back here. Now, on those, there was one scale that I would have actually preferred to have on the 198, and that's a P scale. It's a Pythagorean scale, which allowed you to actually convert quickly between polar and Cartesian coordinates, or polar and rectangular coordinates, as you may say. And also, in electrical engineering, you have a thing called power factor. That is, the apparent volt amps is not the ones that actually create power, it's kilowatts. So you can measure volt amps, and it could be, say, 1,000 volt amps, but you actually deliver and get charged for kilowatts, which may have only been 850. So therefore, 850 over 1,000 gives you a power factor of 0.85. Now with a P scale, you just put 0.85 on the C scale, and you just read directly off on the P scale about, I don't know, 59.6, I think, which would have been the reactive volt amps. Now, usually electricity companies don't get paid for reactive power. So therefore, what we try to do is actually increase that power factor. So what we do is put in capacitors. So that would give me an idea of how much capacitance I would have had to add on to that connection point to bring it back to a power factor of, say, 0.9 or 0.95, which is more in line with what our standards are. Now, also in the defining layout, what are the other scales? There is one here, a temperature scale. I'm not too sure whether you can see that, but it goes up to, on an English system, 167 degrees Fahrenheit. And in the metric system, I think that's 75 degrees centigrade. Now, well and good, that's to actually work out the change of resistance of copper conductor. Usually you've given a specific resistivity of copper conductor at 20 degrees C. So what you can do is actually work out the change in resistance of that copper conductor and use it in your calculations. For me in my job, 167 degrees or 75 degrees C wasn't quite enough. So, and we actually run our conductors sometimes well up to 100 degrees C. So that's why you see steam coming off them every now and then. And also there are other gauge marks, there's constants there. There's gauge marks for horsepower, English system 746, the continental system 736. And here we have specific weight of copper, that's a W's. And here, it's just missing, oh, it comes over here, is an R for the resistivity of copper. We'll go into those a little bit more. There is one up here called M. Doesn't stand for anything. Well, it stands for the reciprocal of pi, not for motor or anything like that. Now, other gauge marks, 287, almost specifically 2.87, is the reciprocal of 2 times the resistivity of copper. That's again for if you want to do a 2-wire system. 736, 746, which is just the different kilowatt numbers for horsepowers. Resistivity of copper, conductivity of copper, and the SI units, the imperial ones would have been that. And interestingly, if you look at the Nestler 37, for instance, had that mark in two places on the A and B scales over the 2 decade scale. You also have specific weight of copper and specific weight of copper in the SI units, or not quite the SI units, but the metric systems. The ones they don't have are things like 2 pi f, which is a normal figure you use in electrical engineering for working out impedance of inductors and also capacitors. 2 pi L is the impedance of a inductor, 1 over 2 pi C is the impedance of a capacitor. Now, on a 50 hertz system, that's not too bad, because 2 pi f is 314, which you have a gauge mark at 3.14 for each pi, so it turns out easily. Not so for our American cousins. They had 2 pi f over there is 377, but those gauge marks never appeared on any electro slide rule that I have in my collection. Now the other gauge marks, the ones I talked about or mentioned before, W and R. There are 2 specific ones on the 378, 398, 198 and the various other incarnations of the 98 series. As you can see, you can read there, the length of the conductor was set on B above the mark W, so yards over W. And you'd find the diameter here, and then you'd get the weight of the conductor. And also, on the other one for R, if you put the length of the conductors on the B scale over the diameter D, you could read off the resistance of the conductor over the mark R. A couple of fairly useful gauge marks. But again, you have to see that all these were based on copper, not aluminium, not an alloy of copper, not steel. So they're only specifically for copper. And in the power industry these days, we use aluminium, we use various alloys of copper, we've used steel conductor. So the gauge marks here were of no use to most practicing engineers. Again, I've just used an example here. The length is set 1,340 yards over the mark W, and if you had copper conductor of 18 mils, you could read off there were 3.94 pounds of copper in that cable. More probably important for people that are actually stealing copper these days and working out how much weight they've got to actually go with it. Now let's just revisit the first, the 368. Going through the images that I've had with these and comparing with Colin Temple, we've got, okay, there I believe it's on the bottom side. Here the cursor extension was on the top side. And here you see no extension on the other part of the cursor. Here you see an extension where the K scale was on that system. So there's all varieties of cursor for the 368 over a period of only something like 6 years. And here I've never seen this one in my life. It's a decimal keeper on the 368 cursor. I don't know whether anybody else has seen it, but I have never seen it. So in summary, especially scales provided some answers to common problems, but they're fairly trivial. And I have no idea why electro rules actually stayed in production, well, particularly the 398 and the other series, the 98 series, stayed in production from about 1930 to 1975. I grew up in that period of using those slide rules, but the 198 was never a favourite with me. I always used a 154 because it had a Pythagorean scale, normal scales that I could use, and 3 log-log scales, and sine and tan scales where I could see them on the bottom edge. I found that the perfect rule for what I needed. And so I have no idea why they stayed in production for that long. I've said here maybe just the Ritz layout with a couple of LL scales produced an inexpensive and efficient rule that many people were comfortable with. But the 154 was, I think, was actually cheaper at one stage, and so I'm not too sure why that stayed in. And in final parts, I would like to thank Professor Carl Klein for actually helping me with some of the parts of the paper, particularly the history and the lineage of Faber-Castell rules. Thank you.
Thanks. Any questions? Andy, go ahead.
The scales you don't like are in the well.
Yes.
Is it the first time that scales were added to the well? So did they have to invent a process to get scales into the well for this cycle?
I don't believe so. It's the same as any others, but
Before, there was a centimeter scale on there, so that you just could measure lengths in the well. So there was a technology to put something in the well, but the use for scales was first with Elektro scales, or was really to operate it, not just measure. Good luck.
good.
Are you aware that Henny copied those nice electroschreibungs from Faber-Castell in the 20s, which was the same design up to the little exact design. But the only difference was the goods, bamboo, wooden structure of the body. And this copy was so striking that the description in France, in the French language, which I have seen from those copies from Henny, was just a literal translation of the description in German from the catalogue in 1908.
Yes, I know that one. Yes, David.
For most of the respective makers, if they had one speciality rule, they had an Elektro.
That's right.
Is there anything that's particular to Faber-Castell Elektros that make them stand out as distinct from the Elektros from other makers?
I don't think so. I think most of the makers took the Faber-Castell Elektro as the design to go with. Nestle were different. They used gauge marks. Unique used gauge marks. And then people started bringing the scales out of the well and putting them on the body, which made you're able to actually bring the scales more into the middle of the body itself. But yeah, most had an Elektro rule and used the scales in the body. Aristo did up until a certain period when they actually brought them out on the 915.
So, that's all.
Thanks.
Said differently, Shakespeare's plays. That's the plan for next year. When? Well, it's always sometime in September, at a date very similar to this year, namely 21st and 22nd of September 2018. So everybody, please take out your calendars, your agendas, and write it down. So, what? Yeah. So, and again, we have a theme, and if it's Shakespeare's plays, it has to be something with that. So it's from sonnets to sums. Okay, you know what to do. Everybody, pick out You go to the bookshop, read your Shakespeare again, find a good quotes to make nice presentations. Yeah? Everybody has to do so. So you recognize the quotes you're presenting, please. Yeah, very. It's at the Stratford Hotel. The Brit and the English have also a sort of tradition, namely to make a display that is to call out and for people and bring along their specific thing for this theme, for display, and that is early British rules and secondly long scale rules. So again, dates we need, a certain notice to intend the paper so that they know what's going on, deadlines and all that. And the important thing is they're really hurried to have those things, everything ready. You can read that all on the website. But first, I have to give a warning or an information. First, there is this place, Stratford-upon-Avon, south of Birmingham. That's the place. But there are several other Stratfords in Britain. Please, Stratford-upon-Avon. What else is on the map? There is a place called Milton Keynes, which is actually not meant, but a place nearby. Actually, a place nearby is something about here. Yes, where we already have been in 2012, namely Bletchley Park. And this is just a reminder, anybody traveling to Britain, that they have there the National Museum Computing, and of course there's also a display by the UK SRC, by the UK slide rule collector. So go along there, have a look, even more, and if you've been there, just a refresher, because lots of that is refreshed because many things there belonged to Colin Burns and were sold a year ago. So, plan your trip. This is a view of the hotel, and most important is next to the date you wrote in your notes, that you write down this web address, this URL, UKSRC or UK, you should know that, and IM 2018.